Inshallah, in today class of several variables, functions of several variables, we are going to continue maxima and minima. How to find the maxima and minima of a given function. In the previous classes, we have done the questions based on Jacobian. Now, in this class, 2-3 classes will be required to do the questions based on maximum or minimum of a given function f. This is first step. In the first step, we have to find, let me find the values of p, q, r, s, t. What is p here? P, q, r, s, t. P is fx, q is fy, and a partial differential with respect to y. R is fxx, partial double differentiation with respect to x. S means fxy, differentiation of fx with respect to y. I will show you the question. T means fyy. So first step is we are finding fx, fy, fxx, fxy, fyy. In the second step, we have to solve p equals to 0, q equals to 0. Or we can say fx equals to 0, fy equals to 0. We will get the points, either 1 point or 2 points or 3 points. These points are called stationary values. Stationary values. Second step, we have to solve p equals to 0, q equals to 0. Or we can say fx equals to 0, fy equals to 0. Simultaneously, both at a time. Then the values of the points are called stationary values. At these points, we may get either maximum or minimum, or neither maximum nor minimum. For that, we have to see these conditions. If suppose rt minus s square is greater than 0 and r is greater than 0, then we will have minimum value at that point, which the point which are substituted, we are substituting rt minus s square. If greater than 0 and r greater than 0, sorry, then we say it have minimum value. Minimum value. If rt minus s square greater than 0 and r less than 0, we say the function has maximum value at the given point. If rt minus s square is less than 0, then we have neither maximum nor minimum. We have neither maximum nor minimum values. And if we get rt minus s square equals to 0, then we say it needs further investigation. Hence, we cannot say what the function is getting either maximum or minimum. We require further investigation. And last step 4 is, now we have to substitute the points, these points, to get the maximum and minimum. Substitute the points in f to get maximum or minimum, values. So must revise this. First step is finding p, q, r, s, t. Second step, solving p equals to 0 and q equals to 0. Third step, we have to find rt minus s square and you have to substitute the points. If we get greater than 0, rt minus s square, r greater than 0, minimum value. Rt minus s square greater than 0, r less than 0, maximum value. And rt minus s square less than 0, neither maximum nor minimum. And if we get equals to 0, it needs further investigation. So let me do a few questions based on this method. Now there is a question, examine the function for maximum or minimum, where a is greater than 0, means we must assume a as positive, a greater than 0. So let me denote this function with f equals to x cube plus y cube minus 3axy. Now just now we have discussed, in the first step we have to find p, q, r, s, t. In the first step we have to find p, q, r, s, t. Just now discuss, now p, q is fx, this is fy, this is fxx, fxy, fyy. Fx means partial differentiation with respect to x. We know d by dx of x cube is 3x square. We don't have x here, 0, minus d by dx of x is 1. 1 into 3 is 3ay cube. The partial differentiation with respect to y, we don't have y here, 0, y cube is 3y square. Minus d by dy of y will be 1. 1 into minus 3ax is minus 3x. What does it mean? It means differentiation of fx with respect to x. Differentiation, you can write like this also. Fx of x. What does it mean? We have to differentiate fx with respect to x. We have to differentiate fx with respect to x. So this is fx. We have to differentiate with respect to x. X square is 2x. 2 3s are 6x. We don't have x here, 0. Fxy means partial differentiation of fx with respect to y. we have to differentiate fx with respect to y. We don't have y here, 0. Y is 1. 1 into minus 3a, minus 3a. Lastly, fyy, we have to differentiate partially fy with respect to y. With respect to y, we have to differentiate y square is 2y, 2 3 is 6y. We don't have y here, so 0. This is the first step. Now for maximum or minimum, what is the next condition? We have to take p equals to 0, q equals to 0. So what is p here? 3x square minus 3ay equals to 0. Q is 3y square minus 3ax equals to 0. Now let me solve this one. Let me do one thing. Let me find y from here and substitute here. So let me solve this solving. Okay, let me note this one, this two, solving 1 and 2. So find y from here. 3x square equals to 3y, ay, 3, 3 will cancel. Bring this a here. Therefore, y equals to x square by a. Now let me substitute here. 3y square minus 3ax equals to 0. Take 3 common. So it will become y square minus ax equals to 0. Now let me substitute the value of y from here. Y is x square by a whole square minus ax equals to 0. This will become x power 4 by a square minus ax equals to 0. I'm adding a take LCM. So this will become a power 4 minus a square into a cube x equals to 0. Let me take common x here. If you take common x here, left with x cube minus a cube equals to 0. Now separate this one, x equals to 0 or x cube equals to a cube. Cube will cancel. So you get x equals to 0, x equals to a. Now we have to get y. Now substitute in this, we'll get y. So see here. Now what we are having, y equals to x square by a. If we substitute x equals to 0, y will be 0 by a 0. So let this point I am denoting by a 0 comma 0. One good point we got. Again x equals to a. Let me substitute x equals to a. What will get y equals to a square by a. That is a only. So let me denote this by b a comma a. So therefore solving, we got a equals to 0 comma 0 1 point, b equals to a comma a points. Now for to see whether this whether we get maximum or minimum, we have to find rt minus s square. Now let me substitute. R is, we are having 6x on the board, r into rt. T is 6y minus s is minus 3a whole square. Now 6 6 are 36xy minus, this minus will become plus, 3 square is 9a square. Let me do one thing, let me take 9 common from here. So rt minus s square equals to, if you take 9 common, 9 fours, it will be left with 4xy minus a square. Let me do one by one after one. Let me substitute first at a 0 comma 0. Now if you substitute a 0 comma 0, a 0 comma 0, what will happen? See here. Now if you substitute x value 0, y value 0, so rt minus s square equals to 9 into 0 into number 0 minus a square. This will be minus a square. We are getting negative value. Therefore rt minus s square less than 0. Just now we discussed, no less than 0, neither maximum nor minimum. Therefore at a 0 comma 0, f has neither maximum nor minimum. Now let me see for b a comma a. At, let me see this for b a comma a. Now you substitute the value, what will happen? rt minus s square equals to 9 into x value a, y value a. This will become 4a into a square minus a square. 4a into a square. 4 minus 1, 3. 3 nines are 27 a square. We are getting positive. Therefore rt minus s square greater than 0. Now to find maximum minimum, we also have to see r value. What we are having r? We are having r as 6x. Now what is the value of x? A, 6a. So this is positive. Since A is positive, this is also positive. Therefore, R greater than 0. So what we are getting condition RT minus S square greater than 0 and R greater than 0. Therefore, we just wrote now F is minimum at B, A, comma A. So we got that. We got the point where the function is minimum. What is the point? A, comma A. At this point means the value of x is A, the value of y is A. If we substitute, then the function is minimum. Therefore, we get the minimum value when we substitute this in the function. Therefore, let me substitute the values. Therefore, last step, minimum value equals to what is the function we are having? X cube plus y cube minus 3axy. Now, if we substitute, what will happen? A cube, x is a, y is also a, minus 3a. This is 3a cube. 2a cube minus 3a cube will be minus a cube. So, this is the minimum value of the function. Now see here, let me start the question. What is the first step? We have to find p. What is p? Fx. Differentiation with respect to x. X cube will be 3x square. D by dx of x is 1. 1 into 3y square, 3y square. D by dx of x square is 2x. So 2 3s are 6x. We don't have x here 0. This is 0. Now p after this we have to find qf5. Differentiation with respect to y. We don't have y here. Y square is 2y. 2 3s are 6xy. We don't have y here. Y square is 2y. 2 3s are 6y. So p q r. R is fxx. Fxx means fx of x. We have to differentiate partially fx with respect to x. This is fx. We have to partially differentiate this with respect to x. So x square will be 2x. 2 3s are 6x. We don't have x here. X is 1. 1 into minus 6 is minus 6. No, pqr s. S is what? Fxy equals to fx of y, partial differentiation of fx with respect to y. So differentiation of partially with respect to y fx means y squared to y, 2 3s are 6y. We don't have y here and here 0. Last figure is t, no t. What is t? Fyy, partial differentiation of y with respect to fy with respect to y. We have to differentiate this with respect to y. Y is 1. Y into 6x is 6x minus y is 1. 1 into 6 is 6. So first step is over. Now the second step, for maximum or minimum, what we have to do? We have to equate p equals to 0, p equals to 0 and solve the for points. Now what is p here? See, this is p here. 3x square plus 3y square minus 6x equals to 0, and q is here 6xy minus 6y equals to 0. Now you see here, what is the easy term? Watch carefully. From here we can solve. No, you take 6y common, 6y, you left with x minus 1 equals to, separate this one, 6y equals to 0, y equals to 6, 0 by 6 0, x equals to 1. Watch carefully. We cannot take point like this 1 comma 0. Here x means we have to take this simultaneously. We have to substitute x here to get the value of y. It is not that the point is 1 comma 0. This from one equation you will not get the point. This equation and simultaneously this equation. So if we substitute either x, you will get the value of y. If you substitute y here, you will get the value of x. So first let me do one thing. Let at x equals to 1. Now if you substitute x equals to 1, 3 ones are 3. 3 minus 6 minus 3. So 3y square minus 3 equals to 0. Bring this minus 3 outside. 3y square equals to 3. 3 ones are 3 ones are. Y equals to plus or minus 1. So we are getting 2 points. X 1, but y is 1 also minus 1. Let we take 1.1 comma 1, another point 1 comma minus 1. Let we denote by a, b, c, d like that. Now next step is at y equals to 0. At y equals to 0. So if we keep y 0, what is left here? 3x square minus 6x equals to 0. Now we take common here 3x. What is left with x minus 2 equals to 0. So separate this one, 3x equals to 0, x equals to 2. So x equals to 0, x equals to 2. So we got these 2 points here. Already we denoted AB. Let this be C0, comma 0 and D 2x is 2, y is 0. So we got the points now. Let me solve after these points. Thus here these are the values of A, B, C, D. Now to find the maximum or minimum, we have to find rt minus s square. The value of r is 6x minus 6 into r into t. T is also 6x minus 6 minus s square. The value of s is 6y whole square. Let me take common 6 from here, 6 from here. 6 6 are 36. Now here left is x minus 1. Here also left with x minus 1. So x minus 1 into x minus 1 whole square minus 6 square will be 36 y square. Now let me take 36 common. Now what is left here? X minus 1 whole square minus y square. So therefore, let me write this. What we got here? Rt minus s square equals to 36 into x minus 1 whole square minus y square. So this is the value we got here. Now let me do one thing. One after one, let me substitute the values. At what we are having, a1 comma 1 and b1 comma minus 1. For both we get the same. Watch carefully. What we get, rt minus s square equals to 36 into, whether you substitute this point or this point, this 1 minus 1 0, so this will become 0. Now if you substitute 1 also here, 1 square 1 minus 1 whole square will be also 1 only, this will be minus 36. Therefore rt minus s square less than 0. Therefore we say at a and f is neither, for less than 0, neither maximum nor minimum, is neither maximum nor minimum at a1 comma 1 b1 comma minus 1. So let me go for the third point, c0 comma 0. See here, next point is c0 comma 0. Now rt minus s square equals to 36 into, if you keep here 0, 0 minus 1 minus 1 minus 1 square 1, this is 0, so this is 36. Therefore rt minus s square is greater than 0. So we will have either maximum or minimum at c. How to find? We also have to see r. What is the value of r? R is 6x minus 6. If you substitute 0 here, 6 into 0 is 0 minus 6 minus 6. Therefore, rt minus h square, minus means less than 0. So this is the condition we wrote, rt minus h square greater than 0, rt minus h square less than 0. Therefore, f is, we don't know, maximum. This condition is for maximum at 0 comma 0. Now how to get the maximum value? We have to substitute this in the given question. Therefore, maximum value equals to, let me write the question. What is question here? X cube plus 3x square y minus 3x square minus 3y square plus 4. So if you substitute the values here, you see here, x is 0, y is 0, so this all will become 0. What is left here? 4. So 4 is the maximum. Now next step, last point. What is the next point? Last point, d. D is 2 comma 0. So what will happen? Rt minus s square equals to 36 into, if we keep here 2, 2 minus 1 1 square, it's 1, this is 0, 2, 2 comma 0, so it is left with 1. So 36 into 1 is 36. Therefore rt minus s square greater than 0. Therefore we will have either maximum or minimum at d. Sorry, for that we have to see what is r. R equals to, we are having 6x minus 6. If you keep here x2, 6 2s are 12. 12 minus 6 is 6. Therefore, rt minus s square greater than 0. R is greater than 0. So what we wrote this? Therefore, f is minimum. Therefore, f is minimum at d2 comma 0. For minimum value, now we have to substitute this value, x0, x3, 2, sorry, y0. Therefore, minimum value equals to, if we substitute x here, 2, 2 cube is 8, y is 0, no, so 0 into a number 0, x is 2, no, minus 3 into x is 2 square, y is 0 plus 4. So let me see what's the value. 8 plus 4, 12, minus 2 square 4, 4 3s are 12, 12 minus 12 is 0. Therefore the minimum value is 0. Inshallah, let me finish this class here itself. Inshallah, in the next class, inshallah, we will do some more questions based on maxima and minima, how to find the maxima and minima. Few questions more, inshallah, in the next class. So I request all the students to subscribe the channel. If you like, you are understanding only, then you subscribe it. You also share with your friends in the colleges. Okay, inshallah we will continue in the next class.